Hello friends, welcome to Gradeup, which is the largest online education platform for GATE computer science, also various competitive exams in India. And here myself, Mallesham Devasane, I am working as a faculty on Gradeup. Here we have very important session, that is practice on operating systems. For various competitive exams, you might be preparing for GATE. Of course, GATE exam just now completed, but might be preparing for GATE 2022 exam and also upcoming exams like ISRO, BARC and maybe IIIT Hyderabad or any other competitive exams like NET. In case if you are preparing for any upcoming exam, then we are going to look at various PYQs like the ISRO PYQs, TIFR PYQs, and if GATE PYQs, if any other PYQs we get, we are going to solve in this series. Yes, at least few questions like 10 to 20 questions we are solving in every session. This is going to help you to revise the concepts in each subject. Yes, in case if you are watching this video, please like the session and also please keep interacting in the session, or you can comment this video if you are watching recorded. Yes, let's begin the session without wasting our time. Please like the session and also subscribe if you have not subscribed to this channel yet. Yes, this session name is the practice on operating systems, which is the 5th lecture in this series, guys. In case if you are not aware about me, yes, I have completed Btech from IIT Bombay. Then I have now more than 12 years of teaching experience and guided more than 1 lakh students, and I have secured GATE. I have secured GATE rank multiple times in my Btech and selected for various jobs. Yes. Now, in case if you are aware of Gradeup and keep coming to the Gradeup app and learn from us. In case if you are not aware of Gradeup app, yes, right now go to the Play Store and install the Gradeup app, which is the largest online education platform where you can have the practice questions to practice every day, and you have a lot of live classes which are freely, and you have a lot of study notes which you can study and learn every day. Yes, this is what we have on Gradeup. In case seriously if you are preparing for any competitive exam, just take the Gradeup Super subscription. If you want to know about the current discount coupon codes, then you can call 96500529904. Yes, you can take the subscription on Gradeup Super to prepare with us. Yes. And let's begin our session. Nishu, good evening. Amit, good evening. Yes, please like the session if you are joined, and let's begin the session. Yeah. What is a compaction refers to? What is a compaction in operating system refers to? Why we do compaction? Right, in memory management you might have been studied this. Sweetie, good evening. Is it a technique for overcoming internal fragmentation? Is it a paging technique? Is it a technique for overcoming external fragmentation? Is it a technique for compressing the data? Yes, I want to discuss each and every option, guys. How many names you give, guys? Father of OS, father of CS, god of CS, or kya? A. What is that A? If you want to overcome internal fragmentation, good evening, Bhartendu. If you want to overcome internal fragmentation, tell me what do you do, guys? Okay, I want to discuss each and every point. If I want to overcome internal fragmentation, what do you do for this? The one best technique is you may use segmentation. Instead of dividing into fixed ones, you can use a segmentation. Even Btech also best option. When I was studying Btech, even 35 years person also did MTech, and he also cracked the placements, guys. Don't worry about the age, Amit. You can learn from any stage if you just have an interest and you have a confidence that you can do. Yes, you can. Clear? Overcoming. Paging will suffer with internal fragmentation. Everybody knows paging will suffer with internal fragmentation. Paging suffers, but who will overcome it? Segmentation overcomes it. Yes, there might be external fragmentation if you are using segmentation, that's fine. It is not a paging technique. Yes, compaction. If any external chunks are left, then this compaction is going to bring all external chunks into one place. That is the right option. You are already saying that. And technique for compressing the data, that you have to use like Huffman coding, right? Any kind of coding techniques you have to use. Sorry guys. This is an easy question asked many times in GATE, ISRO, BARC. Yes, if this kind of question comes, it's very easy. Yeah, next one. A counting semaphore. It's a very just addition subtraction concept. Yeah, what wait operation is going to do? It's going to decrement. What signal operation does? It's going to increment. Then the final value is given to you. But how many times you are incrementing, it is not mentioned. How many times? Just they mentioned x. They want to find out what is the value of x. The initial value is given 7. If you decrement 20 times and if you increment x times, the result is given as a 5. The result is given as the 5. And using this, just you need to calculate x value, which is going to be 18. Yeah, it's a very easy question, guys. It's a very easy question and asked multiple times. And in the semaphore, there are difficult questions, also easy questions. Yes, it is a standard also. Why these kind of questions are important, you should know. It's not just because of easy. You should know in ISRO kind of exams, like you have less time, you have more questions. You have less time, you have more questions. So such questions are going to be very important to solve in the exam. They mostly ask the formula based or concept based, but they don't ask most interpretation based. Interpretation you no need to do a lot. All right. Okay, let's see who will answer this. There is a disk and you have 100 cylinders, that's fine. And they have request 4, 37, 10, 7, 4, 37, 10, 7, 19, 73, 2, 15, 6, 20. This many requests you have, and the cylinder currently at cylinder 50. What is the time taken to satisfy all requests? Each one takes 1 millisecond. Yeah. How quickly you can answer it? Yes, I will explain how to choose it, but how quickly you can answer it? Any answer so far? Yes, here you should be good at calculating or doing addition. You must be good at addition. If you are not able to perform addition properly, then you might do wrong. Yes, on app itself, even in channels also I think we post it. If you are already subscribed to YouTube channels or Telegram channels, then you will get notification too. 119. Yes, anybody else? B, is it 119 guys? Yes, those people who are not able to calculate, let's see how quickly you can do. 50 is there. 50 is there. Let's say 50. Somewhere 50 here. Shortest seek time first. So from here, which is the shortest one? From 50, look at, there are two options. 37 you have, and that is below 50. Below 50, 37, and above 50, 73. Which is the nearest one? No need to look at everyone. Only 37 and 73. 37 is here and 73 here. Which one you are going to choose? Okay, let me number all of them so that it will help me to calculate later on. 2 is there, and then 4 is there, 6 is there, then 7, then 15, then 19, then 20. That's all. Anybody else is missing? Less than 50, less than 50, and above 50, fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. So just you have to look at, if you are pointing here, just look at these two differences, 37. And now from 37, you just look at 20 and 73, because 20, 73, less than 37, 20, more than 37, 73. Who is the nearest one? 20. And who is the nearest one? 19. Of course, you are going to do that. And then 73. So how many moves you have here? How many moves you have here? This is the picture of the shortest seek time first. How many moves you have, guys? 10 is missed. Okay, please do that. 10 is missed. Do you have a 10? Yes. Calculate. Even I counted 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have calculated this. Total 10 requests are there. Okay, 10. Total how many moves you have? 50 to 2. That's a 48 moves. And then till 73. Till 73. So 2 to 73, that is 71 plus 48. 48. Here 48 moves this side. Here this side you will have 71 moves. If you calculate, each move is 1 millisecond. So you also should remember that 1 millisecond for each move. So total 48 plus 71. So 119 moves is equal to 119 a millisecond. Everyone? Yeah. Clear? And if they give 2 milliseconds, obviously you have to do multiplication. 119 into 2. Okay. Next one. ISRO 2017. Yeah. Did I do any wrong calculation? 48 plus 71. All right. Yeah. Mutual exclusion. Mutual exclusion. This is a very famous problem in semaphores. In synchronization, when you are communicating, if the two processes are communicating each other with shared resources, then this is the major problem that you might get. Mutual exclusion problem occurs when? Is it between two disjoint processes that do not invest in anything? Among processes that share common resources? Among processes that do not use the same resource? And between two processes that use different resources on different motion? It's very, very simple one. It is. Did you see that? How easy the questions were coming in ISRO? Yes. when you have a shared resources, when more than one process is sharing the resource with other, of course one process sharing the resources with other process, then you will get this mutual exclusion problem. The what you need to guarantee, at a time only one process should enter the critical section, right? So you can keep the resources, the shared resources in the critical section and allow only one process at a time. Yes, you know that concept. Okay, next. Yeah, page replacement algorithm, optimal replacement. Maybe practically not possible, but very good algorithm. Very good algorithm. Practically may not be possible in real time. You have given some page references 0, 9, 0, 1 and so on. How many page faults you will get if you are using the optimal replacement and initially 3 page frames? The most of the ISRO gate questions, they depends on the 3 page frames because that's easy to apply. Initially 3 page frames are available, then how many page faults you will get? How many? Yeah. Is that A? Yeah. Yeah, myth. A. We already answered it. So those people who have studied and you are not able to recall, let's see that. We have 3 page frames. How many page faults you get it? Anyone else did? Apart from Amit? Quick guys. Yeah. Should I do it or anybody replying now quickly? Doing still? Okay, let me do it then. So initially we have 3 page frames. Okay, now first 0 is coming, but 0 is not available. So Dilip, good question. Guys, why? Practically not possible. In real time, you will not know what are the future references. Here you are requesting, I am requesting 0. How do I know that future next is 9? When you know all the references, then this is recommended. In real time, why this optimal page replacements is not recommended? Because how do you know what is the next request or next page request? Guys, you are operating computer. How do you know that next 1 hour what are the pages you are going to request? Next you may open web page. Next you may open a movie. Next you may open some file. How do you know all these page requests in advance? In every minute you are changing your thought. The page reference can change. Yes or no? Yes or no? Dilip. This is why this optimal page replacement is going to look at the future. Then everybody, L are you going to look at the past? That's recommended if you want it. Is that correct, guys? Is that correct? Yes, A is the right. A is the right. Come on, somebody has to reply. Why we don't of course the best algorithm in the world, when you know all the page references in advance. If you don't know who is next, how can you recommend this algorithm? Alright, first 0 page fault occurred, so I'm just marking it, page fault. Next 9 page fault, 0 already there, 1 page fault. Yes, now look at these 3 are over. Next 1, Now when 1 comes, is already there. Not there, sorry. Now page fault occur. 8. Now 8. These 4 are over. 4 page difference are over. 8. Now look at 8 is not available. Now what do you look at? Will you look at the past or future? You will look at the future, which is not going to be referred in the future. 1 is referred, 8 anyhow that is same, and 7 only think about 190. Out of 190, 1 is referred, 90 is not referred. Yes or no? Then 90 among this, it depends on the algorithm, either 9 or 0 is going to be replaced. So the 0 came first, so I am deleting that. So here I am going to make the entry for 8. I am going to make an entry for 8. I got a page fault. 8 is over. Now 1 already there, 8 already there, and 7 is not available. Not available. Now look at future. Look at future. 8 is coming. Look at only 189. Look at here 189. 1 is coming, 8 is coming, but 9 is not at all coming. So anyhow 0 already deleted. Now 9. In place of 9 we are going to keep 7. We got another page fault. 7 is over. Now 8 already exists, 7 already exists, 1 already exists. Now 2 is coming. Now when 2 comes, look at 178. Look at 178. Who is going to be referred quickly and who is not going to be referred quickly? So 8 is coming early, 7 is coming, 1 not at all referred. So 1 can be replaced with 2. 1 can be replaced with 2. Over. Now 8 is referred, 2 is referred, 7 is referred, and 8 is referred, 2 is referred. When 3 is coming, look at the future. 8 is referred. 8 is referred. Now 2 just referred. Now 7, I may replace or 2 also fine. 7 or 2 is your choice. Anyhow, I am going to delete 7 with 3. So this is a page fault. Now 3 is there, 8 is there, over. So how many page faults we got? 1, 2, 3, 4, 5, 6, 7 cross. So 7. Everybody? Yeah. Clear this point? You are going to replace with a page that's going to be used in future, which is in longest or may not be used ever. Find out the page that is not at all used in the future or is used later on compared to other page frames. Okay. Next. Yeah, you can try for FCFS, other things too. Good algorithm, thread, good program. What is the output of the following program? Yes, how this statement is going to be executed. How many fork statements are there? Only one. But what kind of values? I don't know what output order is, but I know what outputs are. Remember, 2 questions are there. What is the order of output and what are the outputs? Both are different questions. This is about what is output, but I don't know order of the output. Yes, there are 2 different outputs. The 2 different outputs can come in any order. So look at that. A, Amit says A, Dilip A. What about others? What about others? A. So look at how the first parent process is executing. Parent process executing. Say A is the 10. A is the 10. And when the parent process executes the fork, then parent process gets the fork is the return value is ID of the process that is created. So there is another process is going to be created. I'm just keeping the black color. So the child process is going to be starting from here. why child is creating, why child is starting from here? This is the, let's say, parent. Parent is executing here. So this fork command is going to create a child process from the next statement. So from the next statement is going to be here. Everybody? And parent process, what it gets? ID, because successfully creates a child. So return value of the child, let's say some non-zero value. Non-zero equal to 0, it fails. So parent is going to fail here. When the parent executes here, it fails. And the parent is going to start executing directly here. So what is a value for the parent? Is 10. But for the child starts executing from here. It has a, the 10 is incremented to 11 and it is going to print, 11. It's going to print 11. And parent prints 10 and child prints 11. But which order? We don't know. What we know is output is 10 and 11, but is it 11 and 10 or 10 and 11? That depends on who is going to execute first. You know that these two are concurrent processes, parent and child, and both can execute independently, and this 10 and 11 in any order they can print. So 10 and 11 in any order, doesn't matter. In any order. First 10 might print or 11 might print. Clear this point? Only you should know the parent process gets a non-zero for the return value of the fork. So remember this point. The parent process, when it executes fork, the fork returns non-zero, that is ID number. Yes. How it works? Come on. Yes. One possible output. There are two outputs are coming. Parent prints 10 and child prints 11. There are two outputs. Either output is 10, 11 or 11, 10. This is the output. But the order is not known. The order is unknown. Order is unknown. Come on, it's very simple. When the fork statement is executed by the parent, the child process begins from next statement. So it doesn't know I should check true or false because it is not going to start from there. Child process begins from next statement. Who is the next statement? That is A++. When the parent process executes the fork and the child process executes from the next statement. Come on, Pinky. Now, there are two processes are executing. The parent is checking the condition and child is here. Now, these two are independent process. They can run parallelly, but A is different. The child is able to see this A and parent is seeing this A. Everybody? All right. Both have different memories. This is not shared by the two. Who is that? Initially, what is true or false? Where is true or false? It's not initially. You need to think concurrent process. It's not one program. It is two programs. When the fork executed, there is another control comes and it starts executing from here. When the parent is executing this, then the child is created, the child starts from here. The parent sees this is a false, but child executes from here. There are two processes are pointing like this. When the parent executing this statement and the child comes, starts executing. Now here onwards, both are independent. Yes, that you should know. Everybody, is that clear? When the parent is executing here, child starts executing from here because fork was successful. When the fork is successful, then it's failed by the parent and child starts executing from here. Yes. Clear? So you should know that whenever the parent is executing fork, child automatically comes when the fork is over. It returns non-zero, non-zero equals 0 fails, there's a parent job, but child starts executing from here. Child doesn't know if condition, child doesn't know if condition. Alright. Clear? Because child is started executing from here. Because parent told that you execute from the next statement. Yeah, next one. Yeah, here I don't need to talk much about it. Yes, which algorithm it is? Even you see the syllabus, you get to know that. What is this banker's algorithm? It's a deadlock avoidance algorithm. Yes, it's an easy question. Clear? When child prints, we don't know. Guys, in the previous question, who will print first? Parent or child? That's a different, Arman. That's a different. The next statements will be checked by the child. Who will print first? Parent or child? Who will print first? Parent or child, guys? Who will print first? Parent or child? Come on, quick. Who will print first? Parent or child? Yes, I need an answer. Who will print first? Parent or child? Nobody knows. That is the reason anybody can print first. If parent prints first, 10 comes first. If child prints first, then 11 comes first. But answer is very clear, 10 and 11 in any order. 10 and 11 in any order. Because we don't know, because now two processes are executing the same code. One is starting from here and other is here. Now both are independent, concurrent processes. Alright. Now let me give you something. Those people who are not aware of the new upcoming batches on Gradeup Super subscription, you take Gradeup Super subscription so that you can start preparing for GATE 2022 from the next weekend, next Saturday, Sunday. Already enrollments are started from yesterday. Enrollment started from yesterday, guys. And enrollment is going to start for the long-term batch from March 13. So please enroll to the Gradeup Super subscription so that you can start learning from these two batches. If you are working somewhere, you are going for the college, you are so busy, then weekend might be suitable for you. Yes, you are passed out and you have much time in Btech, then we will recommend to learn slowly every day. Yes, weekend people, they will have a little bit burden because they need to manage on Saturday, Sunday. And in case if you need any guidance or support, then call to this number 9650052904. They will help you to take the subscription, guys. Okay, next one. What is it? Yeah, very debate question, guys. Like you said, sir, why optimal is not suitable in real time? Even though it is so very good algorithm, very famous algorithm, best algorithm. Best algorithms always not recommended in real time. It is recommended when it works. Now this one, for the real-time operating system, which of the following is most suitable scheduling scheme? Let's see. We're going to debate like anything. Why not? Why not? Yes, Anonymous. Always there is a discount. Right now there is no discount. But really you need any discount, you just call to the customer care. They will help you to get some discount for you. Yes, right now there is no discount going on, but you can call to this number 9650052904. They will help you to get discount based on your situation. Huh? FCFS? Where is FCFS? Okay, FCFS is there. Okay. Round robin? Okay. What else? This is what I am talking about. Random scheduling, preemptive. What is the best suitable one? Come on. In real time, yes, Bhartendu. In real time, let's see, guys. See, you are running a computer. Now, look at, you opened two browsers. You opened, let's say, two browsers. or let's say in the same browser you open two tabs. In one tab, let's say English movie is going on. In other tab, Hindi movie is going on. Now English movie you are watching. After 10 minutes, you are watching Hindi movie. Then will it be interactive or not? Will it preempt the English movie or not? If not, then you are watching English movie, then parallelly Hindi movie will run and both will get disturbed. And actually you are watching English movie in the beginning and that will be getting delayed because of parallelly you are giving preference to Hindi. So in general, the round robin is recommended if all processes are having equal priority. But when you are watching Hindi movie should be played. When you are watching English movie, that should be buffered. But if you are giving importance to both of them, then it's a very difficult in interactive real time. Yes. So here the preemptive is very important because you might have a priority between the processes. When you have the priorities, then preemptive is very important. In real time, we have priorities. Yes or no? In real time, we have priorities. We never assume all the processes are equal precedence or equal priority. We never assume. You know that. Yes or no? So this is the most important one. Round robin is preferred when all the processes are having equal priority. But real time, we never say we are having equal priority. In real time, we never. Like example, you have a semester exam, you have gate exam, you have placements. Which one you prefer first? Semester. Which one? Because this semester is going on right now. You did not completely passed out Btech, so you give first priority to semester, but parallel you will think about future, what about placements, what about gate. So according to the priority you will give preference. Yes. Next one. Yeah, I think this is another page replacement algorithm. This is LRU page replacement algorithm. Look at the past, least recently used. Yes, preemptive, it should be priority, but words, that is the reason the ISRO most of the assumptions will miss. But in the preemptive, because of you have priorities. Determine the number of page faults. Again, same question. You have 3 pages, everything is similar. Only the algorithm name changed. But they have some conditions. Pages 1 and 2 already has, main memory has already. And which one? Page 1 having brought earlier than page 2. So 1 already there, 2 already there. Now you are starting referring these pages. Let's see what is the answer. I don't know which question it is. Yeah. What is the right answer? One, 2 already available in the main memory. Now start referring these pages. Start from 1. Any answer so far? Guys, if you are watching this video, please don't forget to like the session. Please like the session and also share if you have any friends to join. Also subscribe to this channel to get the notification daily. 4. Yes, one answer got 4. What about others? We have applied optimal, we are applied disk scheduling algorithm, that's a different one. And here page replacement, we are 3 algorithms we are applying now. D, none of this. Pinky. Yes, Banwar, you are right. Poonam also got none of this. Why? You got less number of or more page faults. Don't count 1, 2. don't count 1, 2 because they clearly given main memory already has. That is what the point is. This says that 1 and 2, the page fault not created. 1 already there, 2 already there. No page fault for this because they are already there. It's not empty main memory. It's not empty frames. These 3 frames, among them, there are 2 pages already available. Pinky, that 6 is, if you consider this 1, 2 are page faults. Why are you counting 1, 2 are page faults? No. Are you studying the whole question or not? They are clearly mentioned main memory already has the pages 1 and 2. So 1 and 2, no page fault. 4 onwards, you will get a page fault. 4 not there. So you will get a page fault. Everyone, this is the mistake you are doing. Beginning only you are doing the mistake because you are assuming 1 is, they have not given empty. 3 pages with 2 frames already there. 2 page references. Clear? Now it will become 4. Now it will become 4 because you answered 6. Now you got a 4. Yes. Now 5. Look at the past. 5. 4, 2, 1. Which one you will replace? 5 is page fault again. Which one you replace? 4, 2 already there. So 1 we are going to replace. And then 2 already there. Fine. 1, look at 1 is not there. Look at the past. 2, 5, 4 we are going to replace because this is a list recently used. So 4 we are going to replace 1. So 1 we got a page fault. And 2 already there. 4 not there. Look at the past. 2 already there. 4, 2, 1, 5 we are going to replace because 5 was list recently used. So we got a page fault. How many? 1, 2, 3, 4. 4 page faults. Yes, it's useful means, yes, when you have more pages reference, yes, depends on the reference order. Yes, Bhartendu. When the order is important, let's look at here. 1, 2, 1 brought earlier. Suppose 2 brought earlier. Then this order is going to change, right? Who is going to be replaced? That's going to be affecting. That depends on the order of the pages. These 2 pages might be important. Later on in future, maybe this order might get less page faults. Maybe this order might get more page faults. Right. So initially what you have on the pages, it's very important. The order of the page references is going to decide the number of page faults sometimes. You know that. Have you studied or not? The order of the page references is important. Yes, for this it's okay. For this it's okay. Instead of replacing 1, you might replace 2. Look at, if that is going to happen, the answer might change. Let's see. Suppose we switch, let's say, page 2, page 2 brought earlier than page 1, let's say, then what happens? Let's say we'll just keep like this. So 2 first, then 1, then we'll start 1, 2, 4 page fault, 4 page fault, 1 page fault, and 5. Now which one you replace? 2 you are going to replace. Which one? No, I think it's okay. Again 1 only going to be. Because the order is the 1, 2. If order is different, then it will be. Yes, in the same order, it's not going to impact anyhow. So don't worry much. Yeah, for this order, it's not going to impact. Here 1 is there, here 1 is there. That's all the difference, but you will get the same answer. Yes, when this order is different, then answer going to vary. Okay, don't worry much about it now. Okay, next. Oh, this question asked 3 times, guys. I don't know why are they asking again and again the same question. Gate 2007, copied in 2009 and 2016. Did you see that? In ISRO, what is happening? Same question copied again and again. Okay, let's see. I hope everybody knows about the disk pack. How the disk is organized. You have cylinders. you have surfaces, you have sectors, and you have tracks. Okay. Oh, how quickly you did, Gautami. Amit A. Okay, 16 surfaces, 128 tracks per surface. So total number of tracks you can multiply, and 256 sectors per track, and 512 bytes in each sector. So you have like surfaces 16 and tracks per surface per surface is 128, and you have sectors, number of sectors per track, you have 256, and another one is number of bytes per sector, you have 512. So this information is given. If you want to calculate the disk size, definitely you know, just multiply all the components, clearly given. So 16 multiply with 128 multiply with 256 multiply with 512. This many bytes you have the disk space, disk capacity of the disk. That is the first calculation. Disk size, capacity of the disk. This you will get, 2 power 4, 2 power 7, 2 power 8, 2 power 9. If you multiply all of them, yes, what did you get? 1128, 2 power 28 bytes, which is equal to 256 megabytes, MB. Yes, here when you look at this, these two options are only there. Now, the next question is very important. Number of bits required to specify a particular sector. Yes, if you want to specify a particular sector, now you have to reach here. Now inside the sector, no need to go. Inside the sector, you are not going to deal with the data. Only sector is important. So just you need to deal with these three components. So if you want to look at the sector, then 2 power, here 4 bits required, here 7 bits required, here 8 bits required. So if you sum them, 4 plus 7 plus 8, which is equal to 19 bits required to refer the sector. Yes, to refer the sector, 19 bits required. Inside the sector, no need to go because you are referring the sector. Which sector it is, just require this many bits. If you want only tracks, then 4 plus 7, 11 bits. If you want to refer the only surface, then 4 bits. Everybody, 4 bits to refer the surface, 11 bits to refer the track number, and to refer the sector of a particular track of particular surface, then you require 19 bits. Yes, in the exam, they could ask anything. ISRO 2014, guys. Let's see who will answer. What is the question about? What is the size of physical address space? Physical address space in a paging system which has a page table containing 64 entries. Here you have 64 entries. Total number of entries you have 64. And each one has 11 bits. 11 bits. Each entry is 11 bits. which includes a valid and invalid bit. It's a 1 bit only. So 11 bits is equal to 10 bits for frame number and 1 bit for protection. 1 valid invalid bit for protection. 1 bit for protection. So now 10 bits will refer actual frame and page size is given. And you know page size is equal to frame size. In logical space we call page size. In physical space we call frame size. Everybody knows that, I think. Now the question is about physical address space. What is a physical address space? There's a RAM size. Your RAM. This is a physical address space. What is the size of the RAM? Nothing but number of frames into the frame size. Frame size already given 512 bytes. Each frame is a 512 bytes. This is a frame, let's say. This is a frame. And how many such frames? Already 11 bits out of 11, 10 bits are there. So 2 power 10 frames are there. Because this 10 bits used to refer the frame number. So 10 bits to refer the frame, and how many bits we have here? 512 bytes, right? So 9 bits to refer the inside the frame. Okay, total you have 2 power 10 frames multiply with 512 bytes. Which one is matching? Which one is matching, guys? Space they are asking, right? Space 2 power 19 bytes. C is matching. C. It's the size of main memory. It's size of main memory, nothing but. Clear? C is matching, not A. It's just clear. If they don't give valid invalid, then 2 power 20. If they don't give valid invalid, 2 power 20. Everybody? 2 power 8, just it is the frame size, that's all. But they are asking physical address, total main memory size. Main memory size is equal to the number of frames into frame size. Number of frames you can calculate from the page table entry. Correct? Yeah. One day I will show you, even complete page table configuration later on. How to access all of them. But right now we don't have much time to do that. Okay. Very easy. When you look at this, you will answer very quickly. You can answer very quickly. Please like the session if you have joined late, guys. What happens if logical address requested segment ID 2 but offset is 1000 but limit is 498? What happens? When the offset crosses your limit, what happens in this segmentation? Which option is right? Can it access 2527? No, it will not allow because you have a limit. Is called as a trap. It's going to generate error. A trap is generated. It's not called as deadlock, you know that. And fetches the entry at offset 27 in segment ID 3. No, it's not going to allow any other segment, right? Yeah, very easy one. Yeah, first time when you study segmentation, you study how the segmentation table works to refer any segment. Okay. Yeah, I have less time, guys. Yes, I will discuss this one. Then how many questions left today? Yeah, I think today we have 2 more questions left, but we'll complete with this. Okay, guys, very interesting question. 64-bit machine with 2 GB RAM and 8 KB page size, how many entries will be there in the page table? How many entries will be there in the page table? If it is inverted, means inverted page table. What is the inverted page table definition, guys? How many of you know the number of entries in this page table? Number of entries is equal to number of frames. How many of you know this concept? Because each frame of the main memory will make an entry in the page table. Do you agree? The inverted page table definition. For each frame of the main memory, you will have one entry maintained. One page table entry maintained. So number of page table entries is equal to the number of frames. Now you need to compute number of frames. How to compute the number of frames? How to compute? If this is the main memory, the total size is given 2 GB RAM, 2 GB. The total size is 2 GB. And page size is given 8 KB. So frame size is also 8 KB. Then how many such frames are there? Then 2 GB by 8 KB. 2 GB by 8 KB. This many frames are there. This many frames are there, guys. Then tell me, what is the result? This is the number of frames. How many frames, guys? 2G. That means it is a 2 power 31 minus by, let's say by 8K. That is 2 power 13. So 31 minus 13. 2 power 31 minus 13. This many entries are there. That's equal to 2 power 18. 18. 2 power 18 entries are there here. Like I can write like this. 1, 2, 3, like this. 2 power 18 frames are there. So 2 power 18 entries are there. Everybody, for each frame, you will have a one entry in the page table. Okay. Yeah, this is an inverted page table concept, guys. Inverted page table going to maintain the number of page table entries is equal to number of frames. If there are 2 power 18 frames, then definitely here 2 power 18 entries will be there. Right? Yes. Okay, remaining 2 questions you might try, guys. You may try later on. Yes, just try later on. There are 2 questions I will bring into another practice session. Don't worry about these 2 questions. I will bring, no doubt. But meanwhile, you can practice these 2 questions. And in case if you want to take the Gradeup Super subscription, yes, it is the right time to start your preparation. 9650052904 is the Gradeup helpline number to get the Gradeup Super subscription. If you don't know any discount offer which is going on, yes, which is not going on, in case if you want any discount coupon code, please ask them. They will help you if any code available for you. Yes, don't worry about discount. Yes, you will get something, but ask them, they will help you. Yes. And if you want to know what are the batches which are going to start, the enrollment is started. The classes are going to start from the next Saturday and Sunday. So after 1 week, the classes will begin. And this is the enrollment date. So from this 1 week, the classes are going to begin. Yes. So these are the 2 upcoming batches. One is weekend, one is every day. And please attend the sessions according to your requirement. And before that, take the Gradeup Super subscription with the help of that helpline number. In case if you want to know what teaching on Gradeup, yes, myself, and there are many sessions we are taking on. And look at that, from 12th March, if you are preparing for placements independent of which engineering stream you are, you can start C programming for on-campus and off-campus jobs. Yes, this is going to help you for upcoming the campus, off-campus, on-campus, both of them. And Murli sir is also going to take some sessions like is already taken, I think, about regular expressions. Ankit sir, network security, and Navnit sir, Satya sir, Anshul sir. And look at, yes, Gradeup sahi prep hai to life set hai. So if you want to achieve your dream, if you want to set your career goal, if you want to choose the best career option, then the Gradeup is the one-stop solution for all engineering students. And if you are not aware of that, please go to Google Play and search Gradeup and install. Start using for 1 week. You will understand what is the Gradeup. Yes, you have thousands of questions and hundreds of notes and every day you can ask doubts to your friends, and even experts comes to clear your doubts. So this is the beauty of Gradeup. Yes, thank you so much for joining today's session, and see you in every day. I'm coming to the sessions only to help you, to make you to ready for the upcoming exams. Yes, if you are enjoying these sessions, don't forget to like the session, guys. Yes, also share with your friends, and don't forget to subscribe the channel. Thank you so much. Take care. Bye bye.